Good afternoon, everybody. It's a pleasure to be here with you to share with you what's happening at the National Science Foundation in Advanced Manufacturing. My name is Khargonekar. I'm the head of the engineering directorate at NSF. Just a couple of words about NSF first. We were founded in 1950, and in the so-called Organic Act, which states the mission of NSF is to promote the progress of science, advance the national health, prosperity, and welfare, and secure the national defense. And so Congress has chartered us to do the basic research, so it's a much lower TRL levels, and that's what we have been doing for the last 65 years and continue to do out in the future. In the area of advanced manufacturing, we have two fundamental roles. One is support basic research in all fields of engineering and science that are relevant to advanced manufacturing. Engineering directorate, of course, is the lead player, but across NSF, our expenditures in advanced manufacturing are roughly $170 million, of which engineering is a little more than 80 million. So that's sort of the scale of investment we make every year. And the second area where we play a role is in educating the workforce, the next generation of engineers and scientists that will work in manufacturing. So it goes all the way from PhDs, the scientists and innovators, to master students, to undergraduates who work in our professors' labs, and very importantly, in the community college level, where we have Advanced Technology Education Program, ATE program, that truly trains workers, the workforce for the manufacturing sector. So those are the two big areas in which we work. Before I talk about where we are going in the future, I thought it would be really instructive to see an example of great success from NSF. So this is a picture from mid-80s, I think it's 87, from Austin American newspaper. Shows two professors at the University of Texas at Austin, Carl Deckard and Joe Beeman. NSF, we had just given them a grant to build the first layer-by-layer manufacturing machine. So that's sort of the genesis of what we now know as 3D printing. And so from the mid-80s to 2016 and beyond, McKinsey just put out a report about a year or year and a half ago saying that 3D printing will have an impact of approximately $550 billion by 2025. So we take great pride in having started with a fundamental research project out at UT Austin into creating a whole new field in manufacturing with dramatic economic impact. And so that, of course, feeds into the America Makes Manufacturing Institute as a piece of this much larger set of activities that are going on. And we think, and McKinsey points this out, that this 3D printing is going to have potentially revolutionary impacts. Things like maker spaces are just the beginning. It is going to create innovators. Product design is going to change because product design depends so much on how you make things. So this connection between making and designing is going to change how we think of products, how we conceive of products. And so there's a whole host of forces that are going to be unleashed by this 3D printing technology. And we are just proud to have been a big part of having made that happen. So that's a tidbit from the past. What are we doing now? So this is an example of how our current investments are connecting with other things that you heard this afternoon. So one of our major programs is called Engineering Research Centers, ERCs. These are 10-year, $4 million a year centers that we fund all across the nation. One of them was at NC State, again with partners. It was called Freedom. It was essentially on power electronics. Mark Johnson talked about Power America Manufacturing Institute. So if you look at where the proposal for Power America came from, the dean at NC State, my friend Louis Martin Vega, credits the Freedom ERC as having created the foundational engineering, foundational science that would later on go and become Power America Institute. That's an example. Many other institutes are connected to, at the basic research level, to the kinds of things that we found out of NSF. So for example, the Photonics Institute in Rochester is very well connected to NSF-funded researchers in the area of photonics. So this sort of slide summarizes the role we see at NSF playing into these manufacturing institutes is we connect fundamental research and connect our researchers and graduate students, undergraduate students to these manufacturing institutes. Certainly we are very, very interested, and we help institutes develop their education programs through our ATE initiative. We think of MIIs as really teaching labs. So these are real life factories where our students can go in and get unbelievable experience as they go on and become manufacturing professionals. So we very much resonate with the congressman's challenge. How do we get students into manufacturing? And if they get this kind of experience, they will become just absolutely wonderful contributors to the future of US manufacturing. And we do all of this in partnership with my colleagues on this table. Since Mike Molnar talked about M4Site, I'm going to cut short that part of my comments. There was another challenge that was in the AMP 2.0 report that was talking about creating new areas. And one of them we responded to, and we created a grand challenge around manufacturing, and that led to a cluster of an ERC with 3 industry cooperative research centers on composites. So that we just funded a few months ago. Where do we go in? So I talked about our success in the past, what's happening now, where do we think we are going in the future? So like I said, we have a $170 million portfolio that cuts across all aspects of manufacturing. So I can't really possibly talk about all of the things that we are funding. It's a very rich set of things that we are funding. I'm going to point out 3 directions that we think hold the promise of becoming the 3D printing of 20, put your XX on 20, okay? So let me just talk a little bit about it. I think somebody mentioned we live in a globalized world. So we are very carefully watching what's happening elsewhere. So the report to the left, Factories of the Future, is a report out of EU, where they're sort of beginning to envision what will factories of 2030, 2025 look like. And there's a quote from McKinsey on how Internet of Things is going to completely revolutionize how we think of manufacturing. So we at NSF are absorbing all this, and we have created a program called Advanced Cyber Manufacturing. Okay, this is the new program. We just got it started. We have given a first set of grants, $6.5 million. And essentially, it is asking the research community, the real far-out thinkers, to reimagine what manufacturing will look like in the age of software, communications, computing, and so forth. So you've heard of software as a service. We are thinking of production as a service. Can you imagine an eBay-like exchange where people with capability come in an automated system, and you're a manufacturer, you want to produce something, you configure these assets completely in software, you produce the product where you want it, you ship it out, you collect your money. That's the kind of future we are enabling with these kinds of projects. So production as a service, manufacturing apps. Can you imagine an economy that's sort of built on apps for manufacturing, exchanges, security, predictive analytics, and so forth. Another such effort is a center at University of Cincinnati on predictive manufacturing. So think of this as manufacturing and big data. So how can big data and analytics transform manufacturing to become a very predictive and predictable process? The second direction that we think has tremendous potential is nanomanufacturing. So as you know, nanoscience and nanotechnology have been a major area of investment by NSF and other agencies at this table and others to create the next generation of fundamental knowledge that will create new products and technologies. We at NSF are now saying that we have funded the basic science. We really have made tremendous progress on how to manipulate matter at atomic and molecular scales. It's just unbelievable the science that has been funded by the nanotechnology initiative. We are saying, okay, we're going to move from there to products that can be manufactured at scale, at cost. So there are a couple of examples here that I have pulled out. So the key question we are asking is, how can we do nanomanufacturing at scale? So this is really the most important piece of these projects. And there are a couple of them. One of them is using plasmonics, which is a set of new kinds of materials that can be used to do lithography in a way to print semiconductor circuits, semiconductor chips in a completely new way. Another one is essentially inkjet printing on steroids. So do nanoscale inkjet type printing of products And so that's a project that we are funding at Stanford, Illinois, NC State, and so forth. You have the graphic in your handout, so I won't talk about that. So that's the nano. The third area that we are very excited about is cellular biomanufacturing. So I don't know if you follow the research in cancer, but one of the hottest ideas in cancer is immune therapy, immune oncology. So that's a cover story from Science magazine. I think a year or two ago, cancer immunotherapy was the breakthrough of the year. So essentially, you engineer T cells to go and kill the tumor. That's the basic idea. Tremendous excitement, tremendous progress. We at NSF engineering are saying, well, if this becomes real, we could manufacture this stuff. This could potentially become huge industries that will have tremendous value. So we want to fund basic research to make that thing possible. So the goal of the program is fundamental research on biomanufacturing of cells. So these are some example projects we just funded. We funded 13 high-risk, high-impact projects. I'll just speak about the picture to the right. They are trying to grow heart cells using this kind of manufacturing technology. So this is very early stage. Okay, this is not yet ready for us, but we imagine that one of these projects or some of these projects will eventually become what happened with 3D printing. So to bring my remarks to conclusion, we are planting the seeds. We are planting the seeds of foundational science, foundational engineering that we think are going to create products and manufacturing industries of tomorrow. We collaborate with all my colleagues on this table. We meet regularly, and NSF does its part of connecting our research communities to the institutes and private sector. And we are very focused on creating the innovators of tomorrow. Thank you very much.